So there we go. We're live once more. Been a while since we met here. Two topics to discuss today. One is what is Chris eating? And the other one is, the two topics are, one is the issue Chris opened on the issue tracker about does TTI make sense? Or is it just a weird way of trying to hint at eviction? And the other one is a specific EHCache 3 topic, which is about what do we do for serializers, knowing that cluster is going to introduce a new lifecycle, which kind of breaks the way we've made persistent serializer linked to the disk store work. So we start with the first one, expiry.
Sure.
Go ahead, Chris. State your case.
Let me just pull up the issue. Remember exactly what I wrote. 11 something.
1092.
Maybe one of the triggers for that discussion while Chris look it up. In EHCache 2x, you could actually combine TTL and TTI in the sense that it would take the max expire time of both. And so it means if you, for example, say my TTL is an hour, and after that I have a TTI of 5 minutes, it means entries will stay in the cache, whatever, except eviction, for an hour. But after that hour, only if the entry gets accessed at least every 5 minutes, then it remains present.
Yep.
And the way GSR 107, JCache, and the way EHCache 3 implement expiry, you can no longer do that. Because the get expiry for create, in both cases, will return duration. And if you start with a get expiry for access and you return a value, that value will overwrite whatever the creation or the update released. And so, for example, if you try to do 1 hour then 5 minutes, what happens is that if an entry is not accessed, it will stay for an hour. But if an entry is accessed, suddenly its expiry will move down to the 5 minutes after it was accessed, overriding the initial hour setting. And so on the one hand side, it got me thinking, could we implement that? But on the other side, it got Chris thinking, do we need that? Which is a very different look at the statement.
And my brain got poked into this, well, partly because Tuesday or Wednesday, Louis and I were talking about this in another meeting, and about the problem of, is the combination that you can configure in 2 and the way it behaves, is it possible to build that right now? And the answer is, well, yes, but not easily. But you'd have to store an awful lot of state in the expiry policy, and it'd be very strange, and I'm not sure you could make it not leak, and so on. And there will be much more preferable ways of doing it, and then the question is, do we bad things to the value supplier and so on. And then on Friday, Jeff Gibson, who's another one of the devs at Software AG, he received an email in response to a blog he wrote about a guy that was trying to do this in 107. Well, it was about, can I have both TTI and TTL? And the answer is that in both 107 and in EHCache at the moment, the answer is no, even though it looks like there might be ways of configuring it, they don't do what you think they do, which is a separate problem around builders, the idea that you can call the same builder method twice, and it's a little misleading. But I started thinking after, in conversation with, well, initially in IN conversation with Jeff, and then in direct conversation with Jeff in video conference, of what would that mean? And why would you? And the only sensible solution we came to with what it would mean is what Louis just described, which is that you basically run TTI and TTL independently, and you expire when both say it's expired. Which is this idea that if you have something with a 60-minute TTL and a 5-minute TTI, if it's accessed every 4 minutes and 59 seconds, it never expires, even though the TTL expires after an hour. And so from there, my question was, well, why would you want to do that? And that implies that the accessing to something means something to data freshness. Right? We have this idea that that expiry is used for data freshness and eviction is used for capacity control. So you set the size of the cache to 1,000 elements, and that's to constrain resource usage. But if expiry is only used for data freshness, what does it mean for an access of an entry to modify its freshness effectively, to make it fresh again? And to me, that seems very strange. Things are fresh when you remove them from their system of record, and they become more and more stale afterwards. Why would accessing something make it fresh again? Modulo Louis' weird thing that he suggested, which is a complete anti-pattern.
The one crazy use case I suggested was that if you're on heap and putting mutable stuff, then maybe indeed it means you just accessing it meant mutating it. But honestly, don't do that, please.
Well, there is another crazy case that I thought of in the meeting with Jeff, and I'll mention it in a minute, but I won't know right away. But it's a little more out of left field, maybe slightly less stupid, from a programming model point of view. So from that point of view, the only thing I can think TTI is useful for is a way of sort of saying, oh well, if it gets older than this, if nobody touches it after 5 minutes, then you can just remove it from the cache. But you're not removing it from a correctness of being worried about people accessing it. You're removing it from a, I don't think this is useful anymore. And that's a concept that's getting perilously close to eviction. And then you're talking about, and I mentioned it in the issue, you're talking about this idea of potentially the only reason I can think you'd really want TTI, well, there's two reasons. There's the one I just alluded to, and then this one, which is you using TTI to try and keep the cache via some slightly perverse mechanism, keep the cache beneath its resource limit. And that would be all well and good if TTI were aggressively evicting in the H cache, and it was more efficient than our capacity eviction mechanisms. But the second one might be true at various points in time. It is quite efficient to inline remove something, but the reality is at the moment is I'm not sure we do inline remove things always.
Yeah, I think that sort of reinforces the idea that TTL is for freshness. TTI is not.
Yeah.
Now maybe we need to split them, right? If we retain TTI, TTI should not be part of expiry.
I think TTI is useful for other kinds of caches, maybe. So things like caches where the resource bound is not because you want to keep resources below, you keep usage below this 2 gig because the machine's got 2 gig of RAM, but situations whereby, I don't know, you've written a web browser and you want the disk caches to be within sane bounds. So you evict things out of your local sort of temporary internet files cache when they become older than a certain age.
But again, that's not related to freshness per se. It's
it is capacity control. Yeah. So I'm saying I'm saying you're right. TTI is about constraining the capacity of the cache. It's not such hard constraint as what we currently do, and it's not a constraint I think is necessarily useful. I'm not saying TTI is stupid. I'm saying TTI is stupid in the context of the way that each cache is implemented and written, and its API. It doesn't make any sense. The only other reason that I can think that you might want TTI possibly is you run something like, say, like I think some web proxies work like this, or caching web proxies, where you do a request, and if it's not in the cache, it fetches it from the upstream server, pulls it, and then that's it. And then on a subsequent request, it might you might get it, and the process itself might then do a head request on the upstream server to make sure that the cache thing's still valid. It doesn't need to refetch the whole thing. So you can imagine that with or even like on something like a packaging scheme, where the Debian app, you could imagine somebody implementing the catalog files with MD5s, and so you can cache them freely. But every time you get them, you say, I'm going to get it, and I'm going to do a little network request to check the MD5 to make sure the file's still valid. Oh, it's still valid. Then I won't bother to refetch. And then you know if it's still valid at that point that you can extend its lifetime a bit longer. But you're really talking there about doing something strange you could just as well do with a get
Yeah, and you can do it without that concept, because what you're saying is effectively you're saying stay here longer, but I'm controlling the freshness completely from the outside.
Yep.
And again, so why are you telling it to stay longer? Just tell it to never expire, since you're controlling the freshness from the outside. Oh, but you're telling it because maybe you think it impacts eviction. Well, guess what? We don't need you to tell that. Your access pattern to the cache already tells it. You've increased the last access time. You've increased the hit count. You've done something that we can track in metadata without requiring you, the cache user, to tell us this can stick longer. No, if you've got a usage pattern where freshness is guaranteed by the process you just described, which makes sense in the context of a web proxy, but could make sense in a number of use cases.
Yep.
But then it really is, I want stuff to never expire because I'm controlling the freshness.
Yep.
Then in that sense, sure. Let it be. Yeah, but then it's indeed, as you've said, not TTI. So on the one hand side,
honest, if I were doing that, I'd actually implement that as a custom expiry policy. That actually did the head call. In the Hcache 3, I have the key and value. I'd do it, and it wouldn't be TTL or TTI. It'd be TT.
Yeah,
server tells me it's stale.
You probably don't want to implement that as an expiry policy, because you have got no way of telling, oh, by the way, refresh that. And you shouldn't. An expiry policy should not.
No, it's not telling you to refresh. It's saying if you do the head request.
Oh, you do the head request.
You don't add inside the expiry policy.
God, you're evil. Oh, okay, yes.
Because that's actually the expiry policy you're saying. It's saying.
Well, but then it's interesting. Because then suddenly you've just described a valid use case, and that makes sense.
Expiry policy. For an expiry policy that implements that would implement the get
expiry on access,
the expiry on access, or whatever that thing. Yeah, the access one.
Okay. Yeah.
But I do think those are. I do think those are thin and far between, those examples, and pretty much any way of doing that could just as easily be implemented.
But it has an interesting side effect, though. Is that the way you're describing it? No, yeah, it doesn't work. You can't do it from the internal, because when get expiry on access is invoked, you already returned. You will already return the existing mapping. The only thing you can do is tell it that it's now expired, but you still don't control what the user sees. It's for the next time.
I thought if you return null at that point, that it would.
If you return null, it will preserve the existing expiration, and if you return duration 0, what it does is it says it's not valid after now, but it's still
valid at this point.
If get expiry on access is invoked, it means you had an unexpired mapping in there, and so that's what gets returned. So no, you can't implement it using that pattern. Well, I mean, it would be really weird, which is good, because so Jcache has that get expiry on access. Hcache 3 has it as well, so it won't go away. But clearly, as a cache user, think twice about using a TTI and what it means exactly and what you want to do, and be aware that TTL and TTI are not combinable. Anything you return from get expiry on access will override whatever the previous stuff set. It's only, and you've got no way of controlling that. We don't expose it in the API. You can't know the remaining expiration duration. You don't know that. So if you return the duration, you're overriding whatever was there, potentially shortening the life of the mapping.
And I put 3 things that I think that I propose we should do.
Yeah, and so clearly, yeah. And so I clearly agree with point 1, which is no, we will not add the mechanism so that you can combine TTL and TTI. They make no sense.
Yes.
So that's and so if you're watching this, good for you. And if you disagree, drop us an email on ehcache-dev or ehcache users if you don't want to talk about the internals about your use case, because then we're interested to understand in which case it might be useful.
I mean, I think the most important things that come out of 1097 is not that we will do X, Y, or Z, where X, Y, or Z might include things like deprecating methods, aggressively documenting things, and stuff like that. It's more that it means internally, it means something in terms of how we prioritize the behavior of TTI.
Yeah. So if you're following the ehcache issue tracker, you'll have noticed that at one point there has been some discussion around what we would need to do in order to make TTI work in the clustered use case, which is the big upcoming feature, clustering, not TTI working. And clearly that argument Chris made, which I buy into, means that we will stick with the ehcache 2x behavior, which in short is it doesn't. So TTI just won't work in clustered. You'll get early expiration.
Well, it'll work.
Because yeah, it will work. Yes. But what it means is that if a value gets accessed frequently on a single client, but never gets flushed, meaning that client never evicts it from its caching tier, the server will never know that value was hot and frequently accessed. And so the server may still think, oh, that's a good eviction candidate because I don't see it updated often. Now, if at one point later on we decide, oh crap, that lack of metadata updates hurts eviction, then we may decide to do something, but it will not be to make TTI work, it will be to make eviction on the server better, which is a completely different use case. And so I think I agree with that. And as for the documentation, I believe, yes, we will end up being opinionated in the documentation. Maybe it won't go as far as deprecating stuff, but at least clearly in the documentation, we should indicate. First of all, for clustered, we should clearly indicate we have no pretense of saying it works. But also, we should indicate that even for non-clustered, we believe there is something wrong if you're using that.
Yeah, it's not. I don't have a problem with people using it. I just think that they're getting from it what they think they're getting from it, and they'd be better off just not doing it.
Yeah. Okay.
It's a shame we didn't think of this.
Yeah, too bad. If we had thought of this like a week before, we probably would have pulled stuff out of the public API and added it later if need be. But yeah.
But having said that, I'm sure all of the learned people who will listen or watch this video, you probably don't want to look at it. I'm sure all those learned people will agree with us and would have been totally happy. But part of me also feels like I don't want to pull. TTL is cheap to implement, or TTI rather is cheap to implement in terms of just a filtering point of view. Don't like particularly for unclustered, and I would much rather have it and not have to answer a million times the same question, why don't you have TTI?
Yeah. Although and especially in the context of JCache, which has it, that makes it even more complicated. But yeah,
where it's kind of defensible.
It's not the first time we disagree with the spec.
Let's say it doesn't have capacity eviction, so if you want to be pure,
you use potentially TTI as a way of indicating that can be evicted. Okay, good. Anything else on that topic? Moving on to Serializer. Hoping you can stick around a bit longer, Chris. So this is going to be a short meeting today, Chris.
At least for me.
But yeah. So Serializer. So currently, if you've got a serializer that has persistent state, the way it works is you need to implement a specific constructor so that the serializer can persist its state when it gets released. And that works fine for the open source disk store because we're not crash proof. We're not we're really in a life cycle where we don't care as long as it's in memory, it's fine. And at the end, just make sure you write everything so that when we restart, you've got and taking the compact serializer we have as an example, we make sure we have the mappings between the keys to the class descriptors. Now,
Right.
moving
You
to
get given that constructed. You get given effectively. You get given a directory.
yeah, and what you get, yeah, exactly. And you do whatever you want at stop and at start, by the way. In clustering, it doesn't work that way. As soon as a client puts a mapping in the cache, you need all clients to know to what ID, to what class description a new ID maps. And so not only do you need to do it immediately, you actually need to do it before the operation, so that any client can't reach a state where it sees, oh, ID 5? I have no idea what this is. I need to wait a bit longer to make sure it's there. So you need some kind of consistency in between the two. And while discussing with another developers, I realized that maybe we've got the abstraction wrong. Maybe instead of, because the discussions we've had so far is that we would need maybe another implicit constructor, which would then get past something that would allow it to save its state unclustered. But maybe that's the wrong abstraction. Maybe the abstraction we need is a serializer should be able, if it has state, to communicate that state on request. And then it's inside the Hcache, whether it's the store provider for the disk and the cluster, or whether it's something else, which will take care of requesting that state and persisting it where it needs to be persisted.
Well, I think you've got two things that you need to consider. One is the serializer is the thing that knows that it's that it's altered its state, that needs to be persisted.
Yeah. So
right?
Again,
I'm not. It knows that it's seen a type.
Yes.
And you know
it knows.
Okay.
It knows. So you, if
but
we
you
do
you also want the persistence mechanism to be in control of
when
the persistence. Right. When. Yeah.
Well, it feels to me
maybe there needs to be a speculating here, an interface that the serializer implements, that the persistence mechanisms know about. This is a persistable serializer. And then in combination with that, some kind of a listener, an observer, if you will, that of an event that the serializer can raise, that the persistence mechanism can respond to by saying, the state has changed, I need to do this now.
Isn't it more about the persistable? Oh, blimey, that was not very clever. Sorry, almost sliced my hand open.
Yeah.
I
know.
I've seen blade pointing out the tip of the.
Yep.
I'll fix that while I'm talking. I shouldn't play with tools while I'm working. It feels to me like this is a problem that existed in Hcache 2 as well.
Yeah, but in Hcache 2, the serializer was not part of the public API. We did not allow users to implement their own.
Oh no, totally. But the same problem existed. You had
Yes.
all these things that were sort of
but
required for the functioning of a cache or a cache manager or whatever within the cluster that you needed to scope with the cache. And that's what the toolkit was used for, and so on and so forth. So it feels to me like actually what we're saying is that there's a bunch of adjunct information that needs to be written that is scoped with the cache or with the cache manager or whatever. And it feels like what we actually need is we need some abstraction that can be provided by the persistable resource service.
Yeah, I'm not sure.
That can then be consumed by those things. So those things would be the serializers, the XA transaction manager.
Yeah, so I was going to bring that one up. I'm not sure, and I'm going to explain why.
Good.
So indeed, there is a linked problem to the serializer problem one, which is the XA store journal. Not the store, but the transaction journal that a transactional cache maintains. And it has the exact same logic, meaning that if you were to use the transaction cache clustered, you would want the transaction journal to be clustered, obviously.
Mm-hmm.
My take is we're talking about two very different things. The first one, a serializer, is a type that is part of the public API of EHCache,
Mm-hmm.
where the goal is for users to implement their own so that they can benefit from the performance and the memory space that compact serialization gives them. And they don't really care about all the internals of caches and authoritative tier and the way they work.
Right,
However, we need to know that their serializer has state, if it has.
Right, but isn't that...
At the other end of the spectrum, you've got the XA stuff, which is clearly an EHCache implementer concern. And I agree, we need something better. And we will have to evolve the journal API so that we can do journal discovery that support the same kind of the authority and stuff like that.
To draw the line finer, why can't we? I mean, because you said the XA, which is the EHCache in front is concerned. No, it's because Ludovic's not here. It's the EHCache XA module developer's concern.
Yes.
Who is in principle a separate person from the core.
Yeah.
So the abstraction I was thinking, the most obvious thing is to say that the persistent resource service allows you to create named maps. They're object.
Yeah, but why limit it to a map?
Why limit it to a map? Because it has to be limited somehow. There has to be some low-level abstraction unless you want to give them a byte buffer.
Yeah. But honestly, on the serializer side, for the state, that's what I'm thinking about. Like Clifford said, we probably need some kind of flag to indicate it's been modified since last you asked. But honestly, serializing a full byte buffer, like sending to the cluster a full byte buffer, yeah, sure.
The reason I like the idea of a map is that it allows if it's a byte buffer, right? So you're saying that I serialize a new type, right? How do I send that? How do I tell the the compact Java serializer at the moment, right?
So what you would have something like,
look at compact persistent Java serializer
on each operation, and I agree,
right.
It's made me on each operation. You ask the serializer, any new state? No, okay, don't do anything. Any new state? Yes, okay, serialize your state. Boom, you're done. I can continue with the operation. And if you think about it, it may sound suboptimal at first.
What happens on recovery? How does that data that it wrote down get presented to it for recovery?
Oh, because the whatever is responsible, that's what I said. Either it's the store provider or it's something else. Whatever is responsible for doing these requests and saving them, first, when it initializes the store, looks up and says, oh, that's a store. Oh, it looks like it has a serializer. Oh, the serializer looks like it declares persistent state. Can I find any state? Yes, I can.
Right,
I invoke the method to set up this.
You're asking, do you have any extra state? Oh yes, here's some extra state. Oh, I'll save it. When it comes back, it comes back in one shot, right? What does it look like?
No. It's not extra state. It's the whole state.
Oh, so it has to write that it presents the whole state every time?
Yes.
Why?
Every time. Honestly, I know it sounds crazy, but it's not every time. It's every time a new type is added. And yes, you save everything. Is it huge? I don't think so.
Why not a map? Map is exactly what they both want at the moment.
I don't know.
And
Can I say that a cryo persistent serializer can do all its state saving with a map?
Yeah, because the cryo by its nature doesn't understand you register a specific set of types.
Can I say that a protobuf serializer can save all its state with just a map?
Well, is the map saving only the state of a given serializer, or is one entry in the map
the map
serialization,
is what the map is.
The state?
It's what you use it for. That's up to the consumer. So you'd have a method on persistent resource service where you give it a string or some kind of coordinates for a new map that you want, and it will give you the map. And the map might be empty if it's new, or it might contain whatever was previously at that address. And then you just use the map when you do a put.
And so if you've got a disk, if you've got a disk store, then we give you
if it's the open source disk store, then it'll just give you an in-memory map, right? And then it will just keep a reference to it. And when the persistent resource service gets closed, it'll just serialize the whole thing down. And when it's opened again, it'll deserialize it. And when you ask for it, it'll give it to you. And if it's FRS, the puts will actually be connected to immediate writes, and the resource service knows about what it needs to do when the map gets modified. Like whether it needs to push it down or not, or
cluster it's a cluster map.
And then cluster it's a cluster map.
So you're presenting the whole map to every entity, every object that needs
but they have
to serialize some state.
So the serializer
each one gets its own map.
Each one gets its own map. So the serializer would say it probably uses something like its fully qualified class name. Because it doesn't know if there might be multiple serializers being used for all it knows.
So effectively what you're saying is that in the end, if you can't optimize by putting different mappings in the map, what you could always do is put a single mapping in the map which has everything, and you overwrite it each time you need.
And we can start out just with maps, but if we at some point we decide we need a queue or a stack or a list or whatever, we can do them.
But how do you declare which one you need? Oh, because you get past an API that allows you to ask for something.
You just get persistent resource service starts out with a get map. And you give it a string, and if it exists, you get the map that exists. If it doesn't, you get an initially empty map.
Get state map, yeah.
And if it needs to be changed, if we need to later add a list, we can have a get list method, and a get queue method, and a get stack method, and a get multi map method, and a whatever. And I don't want this to go on forever, but it seems to make sense. The other thing we'll need is the persistent resource service will need ways of binding to both caches and cache managers, effectively, like scoping them both ways.
All right. So you're looking at the map as being something that is observable by observed by the persistent service.
No, it's not observed. It's sourced by it, and since it provides it, the map implementation can be anything we need. Like Chris said. Yeah. Just a reference to an in-memory map.
But it's an active component of the persistence mechanism.
Yes.
Right? So it knows when you've modified it.
It knows when you modify it. You call put on it. It goes, oh, you called a put. Right, I'm going to append a put action to the FRS log.
Yep.
So I'm going to put to the cluster. You mean?
Right. Yeah. And this is essentially what the toolkit was before, except that it did for 2x, except that in the toolkit, the association between a cache and its toolkit structures that supported it, or a cache manager and its toolkit structures that supported it, was purely in the mind of the developer and in the source code. It wasn't actually baked in to the API. Here, we're baking it into the API, which is nice because it means that when you destroy a cache, you can naturally say, well, then I'll destroy all the maps that are in lists and queues and stacks and blah, blah, blah that are that are scoped with this.
Yeah, which otherwise forces us to have something akin to... Well, no, actually, no, it doesn't. But because with my proposal, which I understand is less interesting and less flexible and less evolutive, yeah, okay. And so we would start with a map because that's what we require internally, but we would be open to extension on that mechanism based on requests by serializer.
Yeah, I think map will do an awful lot because
and so it would, but sadly enough, it would be a map of object to object.
I don't think that's the end of the world. It's like a properties map. It's not.
Yeah. It's an untyped. I mean, it's a row map. Period.
I got no problems. If this were public API, then I'd say then as opposed to public.
Well, actually, it might be a map from serializable to serializable this time.
Yeah, it's got to be.
We don't want to go into.
It's got to be able to persist it.
With what? With the serializer? Just kidding. Recursion.
Yes.
The serializer state is in a map which requires a serializer, which has state.
I don't mind making that thing have a generic signature and let Java confer it and put all the casts in and everything. Be a bit hand wavy. That's totally fine. If this were public API, I'd say, yeah, it should all be typed properly and we should persist the types and so on and so forth. It's public SPI. Just grease the wheels a bit. Stick the generics in and make it a little easy.
Okay.
So that way you can call get map and it'll infer the type of the map from your. And if you happen to get it wrong, it'll fail at compile time. But it's our code. We can take the safety off.
Well, some of it, because it's honestly, and from the Java user group session I've started doing, the flexibility of the serialization linked to the fact that you can have a pure off-heap cache, for example, is a killer feature, and so we really want users to be able to use that in an efficient way. Yeah, and so I don't want it to be too complicated.
Chances are, we're going to write a Java serialization one. Someone's going to write a protocol one. Someone's going to write a Cryo one. Somebody write.
I'm not even sure. I think my take, from what I've seen, is that a persistent serializer will be the edge case. I think most people will have non-persistent ones.
I agree, but I think they'll be slightly differently. I think they'll be stateless on the whole.
Oh gosh, yes, that's what I meant. I didn't mean persistent. I mean stateful.
I agree with
I wanted to say stateful.
Effect. Yes, they won't.
Yes.
So basically, they'll be used in persistent and persistent.
Yes, they will be used in a persistent context, but they will be stateless.
Yes.
And stateful serializers will be the exception.
Yes.
Okay, cool. I'll create an issue and start thinking about prototyping APIs for that and see what we can do.
Sweet. I'm gonna go.
That's an answer we need for cluster. So. Okay. Yeah, and then we release you because you were caught in the conversation and probably.
It takes 15 minutes to drive there. I'm good.
Yeah.
I'll put shoes on and put the dogs away, but.
Okay.
Cool.
So guys, thanks for attending, and please come up with questions and remarks on the mailing list. Bye-bye.
Bye-bye.
Good day, all.